All right, here are the first two examples. Basic equations right here. If I'm trying to solve for x, and we're having logarithms, these are called logarithmic equations. And the idea is to get the logarithms together on each side. Now, I cannot draw, even though, here's a temptation. Some of you might say, well, everything's got a log, I can just drop the logarithms. You can't do that unless it's the log of the left side equals the log of the right side. A lot of little logarithms doesn't help out. But I can combine these two logarithms using those properties that we just learned. If you've got addition between logarithms, you can combine them into one logarithm by multiplying those pieces 8 times x. And on this side, it just stays the same. Now that you have the log of the left side equals the log of the right side, the logarithms are unnecessary. You just set those pieces inside equal to each other and then divide by 8, solve the regular equation, you got 3. Okay? So that's just using that first property, showing you how these properties come into play. Same thing with problem number 2, very basic problem. It's subtraction with logarithms. Well, those go together by division. You say x divided by 5. Now you can drop the logarithms where they are. It leaves you x over 5 is equal to 20. And to get rid of division, you multiply by 5. So x is 100. Okay? The third problem in action, the third property in action is this one right here. You got log base 7 of x equals 4 times the log base 7 of 2. I can't drop the logarithms because there's a number in front of that, but we know things in front of the logarithms can go inside as the exponent. That's the third property in action, is that 4 can go inside as an exponent. Now I can drop the logarithms. It gives me x equal to 2 to the 4th. So x is equal to 16. Those are your 3 properties in action and very basic problems. You're probably not going to see problems that simple, but it's a good start showing you where those properties would come into play. So here's the next one. Here's one more similar to the ones you're going to see in your homework and on the quiz and test. Again, got logarithms scattered throughout the problem. I want to combine them into one logarithm on each side. With this problem, I can combine these by saying log base 3, multiplying the inside pieces together. You do have to distribute those, and you get something that looks like that. Okay? Now you can drop the logarithm of 3, logarithm base 3, and just set those exponents equal to, those pieces equal to each other. And then you evaluate what kind of an equation you have left over now. No longer a logarithmic equation, it's a quadratic because the highest exponent's a 2. So I've got to get this equal to 0 by subtracting the 10 over here. Factor that, it gives you x minus 5 and x plus 2. So your possible answers are 5 and negative 2. Now we're going to add one more step to this. One more step is that I'm not allowed to have negatives inside of logarithms. You can't have a negative as a base, but you also can't have a negative in there when you plug in for the x. So if I plug in 5 right there for the x and right there for the x, that'd be the log base 3 of 5, which is good. Log base 3 of 5 minus 3, which is 2, that's good. So 5 is an okay answer. But if you plug in the negative 2 right there, that gives you log base 3 of negative 2. Can't have that. So your only answer on this problem is 5.